So in the last segment, we completed the API that I demonstrated in the initial segment of this class. Now we are going to do something completely different. We are going to look at how things change when you are working with a device instead of a service that talks to a database. So the first problem that I see when people design APIs for devices is that it is too easy to think about what the device does and translate that into the routes that you implement for your API. So for example, if you are creating an API to control your garage door, it's easy to think about it in terms of two routes, /open and /close. Or for example, if you are implementing an API for a camera, you want an API that takes a picture. So that is not the best way to approach things. Here we are going to learn how we are going to apply RESTful techniques and principles to the API that we are going to put in our device. So here I have a Raspberry Pi with its camera module, and we are going to implement an API to take pictures with this. So let's start by seeing the design of this API. You can see here in this slide that the API has two resources. It has cameras and it has photos. So this may seem strange since we obviously have one camera. The API, the Raspberry Pi can only take one camera, but we are going to try to make this generic. So our camera resource will return the collection of cameras when we send a GET request. So you can see that my camera resource has three attributes here. We have the self URL. This is the same as before. When we get a camera, the camera will have its own URL. I have a photos URL. This will give me the collection of photos that this camera has taken. And I have a Boolean property emulated. And what is this for? When I work with a hardware project, I want to make sure that I can continue working when I don't have the hardware with me. So I always create a way to emulate the hardware. And here I have a property that will tell me when I get a camera if this is a real camera or if it's a camera that is emulated in software. So some of you may have a Raspberry Pi with its camera, and for those of you that do, then you will be able to install this application and try it. If you don't have a Raspberry Pi or the camera module for it, then you are welcome to try this application on your computer. Just because I have an emulated camera, when you use this API on your computer, you are going to be using the emulated one. If you run this on a real Raspberry Pi with its camera, you're going to have access to the two cameras. You're going to see the real camera and the emulated camera. Both are going to be enabled. So second resource is photos. So each photo will be a resource. And I don't have a way to get photos globally. I'm only going to get collections of photos when I ask a camera and I get the photos URL for that camera. Now, photos is a little special. I decided not to implement it as a traditional resource with a representation in JSON. Since photos are going to be JPEG files, I decided that when you send a GET request to a photo resource, you get the JPEG. And this will enable me to type the URL for a photo in a web browser, and I will get the picture directly. You can see here that that will be the GET, but I have also implemented delete. So if I want to remove a photo from a camera, I will be able to do that too. Let's go ahead and take a look at this. So if you are doing this on your computer, you can now go to version 0.4. This is the version that introduces the camera application. But I have a Raspberry Pi here, so instead of doing it on my laptop, I'm going to log in to my Pi, which is sitting at IP address 10.0.0.2. And I have checked out the software here as well. So I can go to the camera directory, and this is where the application is. And I'm going to make sure I check out the same version here. There we go. So for those of you running this on the Raspberry Pi, note that I have included a requirements.py.txt. So you will have to create a virtual environment for this project and then install the requirements here, which include the package that controls the camera. Note that this is my virtual environment here, so I'm going to go ahead and activate it. And now I'm ready to run this application. So I'm going to go ahead and run camera.py. And now it started. Note that this time I'm running this on the global Ethernet. So 0000 will enable me from the laptop to connect to the API that's now running on the Raspberry Pi. So I'm going to go ahead and position this camera so that I can take a picture of myself. And I'm going to open a second terminal here. So now I have, on the left, I have the Raspberry Pi session that's running the Flask application. On the right, I have a console that's here on my laptop. So let's go ahead and connect to the public API. This is the one that gets the list of cameras. So I'm going to go to 10.0.0.2 port 5000 /cameras /. And this returns the list of cameras that this API supports. And you can see here that I have 2 cameras and I get the 2 URLs. Note that this works exactly like the database example. Here we request a collection and we get a list of links for the resources in that collection. So now we can send requests to these two new resources that we just discovered. So we can say get and send it to the first of the 2 URLs. We don't really know what they are. I mean, if you read the URL, you will know, but as a client, you don't know. So we can send a GET request, and here we get a representation for this first camera that I have in this API. And it tells me the self URL, it tells me what's the URL for the photos, and it also tells me that it is not emulated. So here we hit a real camera. If instead I send the request to the other camera that I have here, I'm going to get that emulated is true, but otherwise it's going to work in exactly the same way. So those of you that don't have a Pi and are running this example in your computers are going to see only the fake camera and will be able to use it exactly as I use the real one here in a minute. I'm going to switch to the real camera, and now that I discovered a URL for photos, let's see what happens. Let's send a GET request to it. And as expected, I get a collection of photos, which is empty because there's nothing yet. But if you remember from my documentation, my slide, this URL, the photos URL, can take a post request. And that is going to be what takes a picture. We are not taking a picture. We are trying to think in terms of resources. And here we are creating a photo resource. So let's go ahead and change this GET request. Change this GET request into a post request. And because the photo resource is special, it's just a JPEG picture. Unlike the examples with the database, I don't need to add any fields here. This is a post request that takes no fields. So I'm just going to go ahead and send the post request, and this will take a picture of myself. So I see the LED. Now it's going to take a couple seconds, and now we're done. And here we get a location header that includes the URL to our new picture. So let's go take a look at this. I'm going to go to a web browser, put the address, and there you go. This is me. So this is how this API works. I hope this gives you the elements to create and design APIs in a RESTful way. So let's now break out of the Pi, stop the server, and take a look at the application. So let's go to the camera folder and open camera.py. So you're going to find that there are a lot of similarities between this and the database example. So let's start from the beginning. We are using a Python module that controls the Raspberry Pi camera. It's called PyCamera. You can install it from pip. It's in the requirements file, the requirements-py file that I asked you to install in your Pi if you have one. But because I want to make sure that those of you that don't can also use this application, I have this in an exception block. I want to make sure that if this fails, if you don't have this, then I'm just going to signal that I don't have this module and the application will run the same. Here I have a global variable that will hold the list of cameras that this API will support. So this takes the place of the database in a way. Here I'm going to have my cameras and I'm going to use this as my database when I need to respond with the cameras that I have. Application instance, custom exceptions. So this is same as before. Instead of having a generic exception here, I decided to go with two that are more specific. So if there's an invalid camera specified in a URL, I have an exception for that. If there's an invalid photo specified, I have a different one. And this will enable me to create more customized error messages, which you can actually see right here in lines 24 and 29. And here I can respond with a 404 in both cases, but I can use a message that is appropriate for each error. I have my 404, 405, and 500 like before. These are the generic error codes, and I respond with a JSONified dictionary to make sure that the client can parse this and present the error or log it. If I have support for the hardware, if I have the PyCamera package loaded, then I have one more exception that I need to handle. The PyCamera package can throw this exception, PyCamera runtime error, for example, when you try to use it from two different threads or in different error conditions. So I want to make sure that anytime there's an error, I return an appropriate message. So I handle that exception and return service unavailable, which means that I could not access the hardware. Now, as you saw in the demonstration, the IDs that I'm using in this API are not numeric like in the database. I'm using names now. So here I have an auxiliary function that takes a camera ID, which is going to be the name, either pi or fake, and will return the camera object that is corresponding to that name. So basically this goes and accesses the camera's dictionary, the global variable, and if I receive an invalid ID, I will raise an exception, and this will save me from having to handle errors in higher level code, as I explained before. If I get a camera, I return it. So the two cameras are going to be represented with two different classes, but they are going to share some features. So I decided to create a base camera class and then inherit from this one for the two implementations that are specific to my two cameras. So my base camera is going to resemble the database models of my database API. So you can see here that I initialize a camera ID, which at this point, since this is an abstract class, is none. But then I have the get URL and the export data, like before. In this example, I'm not creating cameras, so I don't need to have an import data like I had in the database case. But here you can see that I generate my representation dictionary, and I have my self URL, photos URL, which comes from an auxiliary function, and the emulated, which also comes with a method that I get from the class. Get photos URL is here, and this one invokes URL 4 to get the route that returns the photos. We're going to see this in a minute. Here I'm generating it from the camera ID, which is a property of the object, And again, as before, I'm requesting fully qualified URLs. I want the HTTP and the host name in the URL. Get photos is another auxiliary function that I haven't used yet. And this one will go to the directory where I'm storing the pictures and return the list of pictures that I have in that directory. Here I have another two auxiliary functions, get photo path. This will return, given a file name, return the path for that picture. And I here add the ID of the camera. And you're going to see later how I store these on disk, where I have two folders, one for each camera. And the name of the folder is the camera ID. Note here that once again, if I get asked to provide a photo that does not exist, I raise an exception here so that the caller does not need to worry about handling errors. The last one is the get new photo file name. This is when we create a new picture. I need to come up with a unique ID for it. And in this case, I generate a UUID and I return that as a name. This is going to be a long string of hexadecimal characters. And then I append a JPEG extension to it. Here we have the implementation for the hardware-based camera, the camera in the Raspberry Pi. So you can see that I invoke the base class in my constructor, and then I set the ID to Pi. This is the ID that would set to none in the base class. So now I have an ID and I set it here. It's emulated, is implemented in this class, and it returns false. And this is going to feed the emulated Boolean in the JSON representation. Finally, I have a method that captures a picture. This is the method that uses the PyCamera package to take a picture. And you can see here that this is done by getting a new file name. I use my get new photo file name auxiliary function. And once I have that, I create a block that will start the camera. I set up some parameters here that are hard-coded. So for example, I set the resolution to 1024 by 768. I'm going to flip the camera because the way I have it installed, it will be flipped by default. So I flip it back so that it looks the right way. I start the preview. This will start the camera. It will turn on the LED. I wait 2 seconds so that it warms up, and then I take a picture. And I send the file name that I want the picture to be stored as an argument. So this is all done by the PyCamera module, which is excellent. Anything you need to do with the camera is handled by this package. When the capture finishes, I return the file name so that the caller, which is going to be the route, can return this in the location header. Next, let's take a look at the other camera. This is the camera that you will be using if you don't have a Pi, or if you specifically request the fake camera in your Pi. So this camera does not have hardware, so there's no way to take pictures. So the way I decided to handle this camera is by having a picture that I have on disk. I have it in the same folder as the source file. And each time someone requests to take a picture, I'm going to return a copy of that picture. So here what I do is I open my model picture, I read the binary data from the JPEG file, and I store it in my fake shot property. So now I have it ready and in memory when I need to return it as a picture. It's emulated, in this case returns true, and the capture method is very simple. I make a file name. This is going to be a new UUID based name, and then I open a new file based on that file name, and I write my pre-made picture into that file. So now I have a copy with the new name, and all I need to do is return that name back to the caller, and that will send it over to the client. So here you have two auxiliary functions. These help me set up my cameras dictionary. I need to make sure that those of you running it on a Pi versus not running it on a Pi get the correct list of cameras. So this function will tell me if I have a Pi camera at hand or not. So if PyCamera is none, that means that I could not import it, so I will say no. If I do have a camera, I want to make sure that I can open it. So I try to open the camera and start the preview, and if this raises an exception, I know that I don't have a camera. So in that case, I'm also going to return false, otherwise I return true. And with the help of this helper function, I create my camera's dictionary. So I know that my fake camera will always be there, and if I have hardware, I'm going to add my PyCamera. So all that is left is to look at the routes. So let's see the two GET requests. Here's the cameras slash. This is the one that returns the list of cameras. And you're going to see that this is almost identical to the database example. The only difference is that instead of a database, we have a dictionary. But we go through all the elements in my cameras dictionary, and for each one, I call URL for. And that gives me the URL for each camera. So I will return that list in a dictionary indexed by key name cameras. The next one is the one that returns the information for a specific camera. So here I have a camera ID, and note that I don't specify int like I did before, because this is not going to be a number. This is going to be the camera name. So I get that as an argument, and all I do here is use my auxiliary function getCamera from ID, and if I get it, all I need to do is call export data on it, and that gets JSONified and sent back to the client, and that will be the representation for that camera. Next, I have my photos collection for a camera. So this is going to be the URL that gets returned as part of the representation for a camera. Clients will discover this URL when they request the camera. And here I have the camera ID as part of the URL because I want to support both cameras with the same route. I receive my ID as an argument, so I can retrieve the correct camera from my dictionary that takes place of a database. If I have photos, I can get them by calling getPhotos. This is the auxiliary method I showed you earlier. That will give me a list of file names that have photos in this camera. And what I do with that is pretty much the same I do with databases or up here with cameras. I just go through each one and I convert it to a URL. So then the client will receive a dictionary indexed by key name photos, and the value is going to be an array or a list with all the photos that this camera has taken, and that will be in my file system. So then let's say I took a photo and now I want to view that photo. This is the example that I showed you in my web browser. So this is the route that handles that case. So this is going to be a GET request. It's going to be specific to a camera, so I have the camera ID in the URL. And there's also a UUID for the picture. This is going to be part of the URL that is returned in the post request in the location header. So I have a second dynamic argument here for the file name. So my route will receive two arguments for the ID and the file name of the picture. I can get my camera as before. Once I have a camera, given a file name, I can ask the camera to give me the path of the picture that I want, and this is a support function from Flask, I can send that file over to the client. And this function is really nice because it takes path to a file and it will look at the extension, set the proper content type, and send it over to the client as a static file. And that is why when I go to my browser and open that, I really see no difference. It looks like I'm opening a static file, even though this is being sent by a dynamic request. So here we have the most interesting one. This is the one that takes a picture. So this is a post request to the photos collection URL. And here I get my camera and I invoke capture on it. That returns the file name of the new picture, and I then return a JSONified empty response The code is 201 because I created a new resource, and the location header has the URL for that resource. So as you see, this seemed very complex and now ends up being extremely simple. There's one that I didn't show you in the demonstration. I have in this API the ability to delete a photo. So if you send a delete request to the photo specific URL, the one that includes the camera ID and the file name, and the method is delete, then I'm going to go ahead and grab the camera, obtain the path to it using getPhotoPath as before, and then use file system functions to remove the file from disk. And if that was successful, then I can return an empty response. If this is not successful, then there's going to be an exception, and I don't have to worry here because, as I said before, I want my routes to be as linear as possible and very clear, so I try never to do error checking in the routes. And that's pretty much the end of it. The remaining bit is to start the server, and as I mentioned earlier in the demo, I started using the globally known Ethernet address, and that enables me to access the API running the Pi from a different computer, here my laptop. So before we end this segment, let me show you how the fake camera works so that you don't take my word for it, and you can see, at least for those of you that won't be using a Raspberry Pi, what you can expect. So let's quit this, and since I have my Raspberry Pi running, I'm going to run it there again. So I'm going to go back to my Pi and get back into the project, activate the virtual environment, and run the API. So there we go. I'm going to get my list of cameras using my public API, and now I'm going to go with the fake camera. So I'm going to copy that, send a GET request. That gives me the photos URL. So now I can send a POST request. So you can see there's absolutely no difference between working with hardware or working with a software-based emulated camera. So I'm now going to take a fake picture. That's very quick, and I get a URL that I'm going to copy. I'm going to go back to my browser, paste it, and you can see you get to see a picture of my beautiful cat here. And every time you take a picture with this fake API, you are going to see this picture unless you replace it with your own. So that is it for now with hardware. Near the end of the class, we are going to go back to the Pi and look at some more advanced features. But for now, we're going to stay with the Orders project and improve on it.